Heliocentric physics. This history is, in a sense, the most important of all, and the one which connects with physics today. Of course, it is very necessary to understand the stretch and extent of the phenomena that we now call the first scientific revolution. But we are now living in the second scientific revolution. We call it the first scientific revolution because despite the Greeks' remarkable mathematical feats, what we call modern science did not arise in Greek times. Of course, the first scientific revolution is associated with such tremendous events as the discovery of the nature of the solar system, discovery of universal gravitation, the properties of light, of the vacuum of gases. In fact, with discoveries involving all the main branches of physics, as we know them today, of course, but it is also associated with a very different way with the events of the time. Of course, it is a peculiarly European movement, though, of course, it has now spread all over the world globally. And so one of the great historical problems which has not been solved and may not yet be susceptible to solution is to find out why this revolution happened, when and where it did. Of course, we can offer good negative reasons. We can see very good reasons why it could not happen in different circumstances, but that is not sufficient reason. Of course, it is a necessary one, but not sufficient. So we might be able to look at the material circumstances and the freedom of the people who were there and what they had to work with as well. Of course, we know that in the absence of certain factors such as interest, money, technical abilities, in mathematics, for example, the first scientific revolution would not have taken place, of course, but we do not know why it did not happen in classical times, which were as wealthy in different parts of the world, such as India, as well as China, as well as over in Western Europe. Of course, these areas had an abundance of clever or extremely clever men, men of genius, and yet they did not take this particular step. It is associated in Europe with the two other phenomena of which you might have read in other history books, of course, and a third one which you may not necessarily find there. Of course, these are the Renaissance and the Reformation, which I have read about. We have tons of lectures on it and readings about. It's producing the event which fits the transformation better than the Reformation, namely the rise of capitalism. Of course, however, we do have different histories on these particular time periods. Time periodization is something that historians have to do to kind of make sense and give continuity to a world of constant change. And so, when one thinks about the Renaissance, one thinks of it essentially as an artistic revolution, one in painting and architecture and, of course, manners of life, as well as in poetry and so forth. But together, these represent a change in the economy, in technique and attitudes towards the world or behaviors thereof, which were reflected in changes in religion as well as in the physical appreciation of the world as well, not to mention the historical writers of the time. Of course, now, what do all these mean taken together? I cannot give here a historical analysis. It would be wrong to do so, but I do need to sketch in enough background in order to see where the different parts fit in. The scientific revolution essentially moved in stages. We can discern roughly three major ones: a preparatory stage, which by convention more than anything else starts in the year 1453, the date of the fall of Constantinople, and in the end, as it were, of the last continuity of Greek culture. This preparatory stage goes on until about 1543, 1 century later. Another useful date because it is the year of Copernicus's revolution, which destroyed the old conception of the world, the old earth-centered version of the world, geocentric. Of course, the central place of the earth in the universe. It is essentially a critical stage, one where the old system was examined and found faulty, and where the lines of the new system were working out. In the next stage, which is, as it were, the crest of the wave, is the Renaissance, followed by the Reformation, carrying us on into about the year 1620, the early 17th century. That period covers the filling out of the picture of the solar system by Tycho Brahe and Kepler, Johannes Kepler. And of course, it also covers the development of the telescope and the optical and dynamical discoveries of Galileo Galilei. The central period of the 17th century takes us to the year 1687. the date of Newton's Principia. With its publication all seen to be tied up and codified, it was such a decisive achievement, in fact, that it had the effect of marking a definite break in development. Once Newton had completed his work, it really did not seem at the start that it could be much to be improved upon, so people did not try to do so for another 100 years. I guess one could say the same of Aristotle, of course. And all this built up to the first scientific revolution. I forbear to mention here that other aspects of it, for example, the biological aspects, although the period we are considering include William Harvey's work on the circulation of the blood. But of course, the fundamental advances were discoveries that destroyed the Greek worldview, first through the development of anatomy, the working of the human body, and of course, second, through the discovery by experiment and observation of how the solar system works. Of course, previously things above, celestial things, were for observation only, and the people on earth could not be expected to understand how such divine objects moved. This was expressed by saying that they were moved by angels or they were moved by celestial mechanisms. At any rate, however, they were moved by some kind of mechanism which we did not have on Earth. Of course, with the developments of this period, particularly the work of Johannes Kepler, we get the picture, which was completed by Sir Isaac Newton. And of course, the dynamics of the world and being transferred to the heavens, of course, incidentally, this work completes the circle to the extent that the discovery of how the heavens work was considered as the main object of science, or that of physics. And so this was because the motions of the heavens were considered to be intrinsically at the beginning of the problem, the most pertinent thing that there was in the universe. Of course, the whole fate of life and everything else was tied up in the movement of the heavens. The heavens ruled the earth. Therefore, whoever understood how the heavens worked would understand everything on earth. And here we're just talking about the cosmos. We're just talking about the universe in general, or the celestial spheres that go around in the sky. And so by the time of Newton's work, the time that it was understood, it was then realized that the heavens do not rule the earth, that the problem was, in fact, not a terribly pertinent problem, and its solution likewise not important. But what was pertinent was the means of arriving at the solution. In arriving at the solution, Newton discovered, or Galileo and Newton together, discovered the new science. So Galileo called it the two new sciences, one being dynamics and the other statics. They also discovered the corresponding mathematics, the mathematics of the differential equation, which has been the basis of the whole of theoretical physics. And of course, this was not the original object of the exercise. However, it was simply the means of solving the problem of the structure of the universe. But of course, then, it found other uses as well. In this period becomes the beginning of the foretaste, as it were, of the Industrial Revolution, that of the steam engine. In the study of the vacuum, for example, we see the discoveries of Copernicus, Galileo, Kepler, and Newton. But there is another person who should be put there as well, for he was part of the general picture, and of course, in a real sense, its originator, and that is Columbus. In the year 1492, the year 1492, Columbus sailed the ocean blue. Of course, the change in Europe as well. We'll talk about the historical context. We will go back and think about Europe in this period. I say think about it because the change occurred in Europe, and at that time, it did not occur anywhere else for entirely historical reasons and context, which we will need to explore further. The Mohammedan world had taken a terrible knocking down from the Tartars. It was much nearer to their base in Mongolia than was the Christian world. Of course, by the time they had reached the Christian world, the Tartars had run out of steam, and at any rate, they had reached as far as they wanted to go by about the year 1280, so late 13th century. And they had just penetrated the boundaries of the German Empire, no further. But they had destroyed and massacred the people of Baghdad, and they had generally chewed up the Eastern world, of course. This included a great part of India, as well as China and Central Asia. The Eastern world, except one country, that of Egypt, was just out of the reach. It had been so heavily battered that it was not likely to be the source of any great scientific advancement at that time. Although the Tartars gave way to the Turks, and the Turks did not develop much of whatever that they inherited, however, there was more in recovery than merely recovering from battles, but there had been a whole attitude towards life, and this had been shattered long before by the first rising of the Ottoman Turks in the Near East in the 12th century, so the 1100s respectively. The idea of progress, the idea of finding out new things was being actively repressed, and then in the interest of Orthodox religion. In the meantime, however, a great many things had happened in the West. The West had a backward region, what might be called an underdeveloped region, although it was already building a civilization of its own. The most underdeveloped part of that region happened to be Britain because it had never much civilization. It had been only on the edge of the Roman Empire and consequently benefited less from Roman civilization than anywhere else, of course, being a part of it on the Isle. Of course, the important thing about Britain, and to a lesser extent the neighboring countries of the lowlands, that of Holland and Flanders, was that they were on the edge of the continent. They bordered the sea. To a very large degree, the whole process about which I am speaking about is one that comes from the exploitation of the sea for two purposes. One is for trade and the other is for food, or fish. And of course, one great revolution was brought about by something very small, the change in salinity of the Baltic Sea, which drove the herrings out of the Baltic into the North Sea and made fortunes for the people in the Low Countries in Britain. This gave enormous encouragement to navigation. You might remember that navigation was the sphere in which science could be most immediately useful, particularly navigation in the open sea and not in the closed seas such as the Baltic and the North Sea, as well as in the Mediterranean, of course. So navigation was the key, or the keyhole, to the utility of science. And we're talking about the ships that were constructed in Spain, constructed in Portugal, and as well. And of course, the characteristic kind of economy that existed in Northern Europe was, first of all, a subsistence economy. The manorial system was composed of farms which produced nearly everything that they needed except for iron and salt. But in the 13th and 14th centuries, respectively, they were short of people, and people partly due to the Black Death. They had more land than they could cultivate, they had more things to do than they could find people to do them, and this was the opposite of the state of affairs that had existed for a long time in the classical era. Again, we're talking about the era of classical antiquity, the ancient world. And as a result, there was a premium on doing things mechanically. I have already mentioned that according to the Doomsday Book, or what's called the Domesday Book, there were 5,900 water mills in England. And these mills not only ground flour, but they also helped to finish cloth by as well. And so there was another element, trade. In the first stages, there was no trade in the roughest of raw materials because they could not be carted about profitably. There was little trade initially in corn, but there was a very considerable trade in cloth, and the most elaborate trade in that. Of course, the cloth trade, which started in Italy, gradually spread over the Low Countries and then to Britain. We had no person in Britain who could do any fine weaving until the year 1350, middle 14th century. We had to import weavers from Flanders to do the weaving and other treatment of cloth, and so England produced rough cloth. The fine cloth, as well as the glory of the late Middle Ages, came from the birthplace of modern science, that of the Italian city of Florence. Florence was, so to speak, the Leeds of Italy, the place where wool was worked up, the great Florentine houses, and grew up in the wool trade. They developed fine wools. They obtained their rough wool from England, worked it up, dyed and finished it, and sold it back to England. Just as later we worked up the Indian cotton and sold it back to India. The point here is that it was in those countries operating the textile trade where there was accumulation of capital sufficient to get the whole process of the Industrial Revolution going. Okay, and we could talk about some of the metalworking and everything. We could talk a little bit about the other features of this time. And we're definitely going to talk a little bit about the revolution in astronomy. And you mentioned navigation, so we're going to have to talk about navigation for a little while. Then we'll finally move on to the Copernican revolution. And then we'll talk about Kepler, Galileo, and Newton, Brahe. So we're going to cover all of those. All right.